Hey everyone, it's Jake Hall, the Manufacturing Millennial, talking to some amazing subject matter experts that have such a passion for robotics and the automation space. I talked with Ed Marchese, who is head of automotive industries here at ABB Robotics. Ed, how you doing?
Nice to meet you.
Nice to meet you too. Thanks so much for taking some time. Before we dive into what is changing in the robotics space around automotive, let's talk about you.
Okay.
How did you get involved in this industry? What drove you to your passion for robotics and being where you are today?
I got into automation over 25 years ago, and it started as a friend of mine said, hey, we have in our automation company, I was right out of college, they were looking for someone to send to Europe and get them trained in the ways of automation, and it started my entire career.
Yeah.
It really took off from there. So I've always worked in the automotive space, in automation, and I've always worked with ABB Robots, and I'm super proud to be a part of a team here that does automotive automation solutions that have great products behind them.
I love it.
Yeah.
I love it. And when you think of the beginnings of automation robotics, you have to look at the automotive industry, right? That's where so many things started. That's where the robotics was introduced. It's still across the board the pretty much number one industry of where industrial and collaborative robots get entered into. So when we look at the 25 years of experience that you have had, what have you seen change the most when it comes to how robots are used in automotives?
Sure. Automotive really took a hold, I would say, paint was one big one, and that's still a very big staple of what we do, so paint robotics. The other area that's really caused a lot of growth has been how we can do things flexibly, right?
Yeah.
So I've watched everything evolve. From when I first got into the business, there was very few robots, and everything was hard-tooled. And over the years, robots were added where robots can do things more flexibly.
Yeah.
It could change a lot in the business in terms of, you can change the end effector on there, or you can have robots working together to do complicated tasks. So no longer just doing material handling, let's say, and you could really we've done some really crazy things over the years, but also, doing things that otherwise would have been more costly to do with hard-tooled automation. And then, of course, in the more recent years, the collaboratives have come onto the scene, and really opened us up to how robots can work in the way that humans can, and leverage that sensing capability to maybe make things fit together the way humans can do.
Flexibility is such a massive demand when it comes to robotics these days. And when we look at the demand, I think I saw a shift happen from traditional automotive for many years when it came to the design around a car with a combustion engine.
Yep.
And then we saw a transition happen where more greenfield facilities were being built around the electrification of vehicles, and even the way we want to integrate, the way we want to program, the way we want to deploy these solutions.
Right.
What have you seen change when it comes to separations when you're working with a combustion engine customer for a line and a electric car for a line?
Well, I'd like to point out that part of the journey, the people in manufacturing space that were previously in ICE powertrain, they also got involved in hybrid powertrain.
Yeah.
So, and that transition seems like it's going to be lingering a little bit longer right now.
Yeah.
But for those of us that got involved with it, it's a much simpler transition. Now, the battery aspect of it was kind of new, right? But when we look at that, well, what did that bring that lends itself towards robotic manufacturing is you have a lot of repetition, repetitive manufacturing tasks, because there's a lot more multiples inside of an EV. So you'll hear many people say that the EV has fewer parts. I'd like to take one apart actually down to the pieces and pieces and pieces, and you'll find out that things such as the rotor inside of the drive unit is made of maybe 4, 6, or 8 laminate stacks, but those stacks are 30 or 40 pieces. And there's 200-300 magnets inside of one of those, right? So if you took all the pieces out, or if you say the battery is one piece, but maybe there's 20 modules inside, and in those 20 modules are 20 to 30 battery cells, right?
Yeah.
So when you start doing all the multiples, what it brings to light, especially in robotics, is that in order to get those multiples, and you compare it on a per vehicle basis, you realize that there's a lot of multiples per vehicle. So it's one battery pack, but it might be somewhere between 600 and 800 battery cells in there. So yes, it's maybe 20 modules, 600, 800 batteries, right? So you see the fact that you have to do an upscaling. So you may solve the problem with automation, but you're going to need to do multiples of those pieces of automation. And that's really what the EV transition has brought about that's different. So where we had robotics in ICE powertrains, it's been amplified further now because we have to do multiples of the same thing over and over again.
At a much larger, higher demanded scale.
Right.
So when you look at the transition as well, we're having a great conversation before we turn on the camera, and that comes to, we don't want to say we physically reach the capabilities of robotics when it comes to payloads and accuracies and precision, but we see the next leap forward being a digital leap forward within robotics and the way we touch and program those robots. Can you elaborate that a little bit more?
Absolutely. So, as a robot manufacturer, ABB's always got one foot into the future on what it's going to do next. And they started thinking about this some years ago. We've launched a whole new product line and a whole new software capability to run that new product line. And what we see is that we are leveraging, and I'll give you the example of the young kid who, today's generation that's now entering the workforce, they grew up with an iPad that had a little app on it that had a ball that they can program to run through a maze. And how did that work? Well, they taught those kids early on how to do drag and drop software right on a tablet. Well, guess what? All of our applications now for basic programming of a robot can be done through those tablet applications where people can drag and drop the software and create it. We not only have that in our industrial robots, we have that in our cobots, we also have that in our AMRs. And so it's a similar common interface for what today's generation is accustomed to from when they were young children, and that's going to help us bring in the next generation of robot programmers, and it makes it easier for them to onboard.
Well, and I think about it, right, from every young boy or girl who grows up is playing video games, is playing with a joystick, is playing with a mouse, is playing with a thumbstick on a PlayStation or Xbox controller, right? And and you want to show how do we get this next generation excited? So you know what? We're taking what you played virtually on a screen. You can still play it on the screen, but look at this robot that you're now moving in front of you that's doing this operation and building your favorite, vehicle or packaging your favorite food or drink. It's that relation that all of a sudden gets kids at a lot younger age saying, I'm capable and more than doing this. And I would think for a lot of first-time users as well, right? Where robotics in so many ways was intimidating, right? You have a teach pendant that you have no idea what it looks like. It's been that way for decades and decades and decades. How do you have someone who's never touched a robot before from a tier 2 or tier 3 automotive supplier who wants to automate? How do you get them introduced?
So at our Auburn Hill facility here, we have the capability to train over 5,000 people a year, get them in here, get hands-on. We have all different sized robots we can train on. We have our software platform. We have our wonderful teach pendant. It's a touch screen. It's color. It has hard buttons. It has a joystick. It has everything you would need to be comfortable very quickly and get your hands on it and really absorb the technology very quickly. So we're very proud of being able to do that and bring new people into the fold all the time because as you know, with the cost of labor in the U.S. and all the onshoring that's happening, and everybody's looking to automation to help offset some of the challenges that we have here to be globally competitive. And so, really, the demand is there. We're in a great industrial market here. We have a great, a great support team here in the U.S. to support our customers. Tier 1s, Tier 2, Tier 3. I mean, we are truly prepared and excited for what's coming in the next wave here.
I love it. So if you were to take a solution, technology, and put it 10 years in the future, what makes you most excited about robotics and automation in the automotive space 10 years from now?
What makes me most excited? The fact that it's not going away, it's only getting more intelligent. Right? And so everybody's a buzz about AI right now, okay? And we have some AI aspects to what we're doing too. Whether it's machine learning and application that can help us see things. We heard previously, it's been 10 years now since we've been having the Industry 4.0 conversation, right? It hasn't quite proliferated beyond experimental things in the really hardcore manufacturing spaces yet. So while we have a ton of data we're sitting on, there's a ton of insight, I think we're going to start to see in this next wave that we're actually doing something meaningful with
Yeah.
it and solving problems that we couldn't solve before.
And it's becoming a lot more accessible, just like robotics across the whole here is. You know, when you have 5,000 people coming through this training facility with us every day, seeing all the different lines with the paint line right behind us as well, that's teaching people how to do coordinated motion and the painting. It's giving them that introduction where robotics is a great leap forward that is not the risk that they once thought it was.
Correct. And I see it when we bring in the college age co-op students. These students are very mechatronic in their focus, which you need to be. You have to. You can't. You know, previously, where the world I grew up in engineering, you were mechanical or you were controls. Right. And that's not good enough anymore for tomorrow's generation. Right. So they're coming in now with that background. They've all had. They were on their robotics teams in school. So they cut metal, they assembled things, they programmed.
They wired the controller.
Exactly. They solved problems. It fell over. How are we going to make it not fall over? When So they have they're coming in with a strong set of basic skills. That's just truly amazing, and it really excites me to see that.
And it's one of those things, right? For every 2 people retiring right now, you need someone to come in, and that person's got to take both their jobs, so they can't just be an electrician. They got to understand, I got to weld and I got to program at the same time, and be able to retouch a robot and make changes.
That's right.
I love it. Ed, thanks so much for your time.
Thank you so much.
I really appreciate the conversation. Of course, if you want to learn more about what we're doing in the industry and what ABB Robotics is doing to push this industry forward, I'll have some more information down below. We'll see you guys soon.